In the absence of damping, determine the equation of motion. If the mass starts from rest the equilibrium position, we're going to use the basic formula, Ft equals kHt. We have m equals 100 grams equals 0.01 kilograms. K equals 1600 dynes per centimeter equals 1.6 in per meter. H equals sin 8t, the inclusion of Ft in the formulation of Newton's second law gives the differential equation of driven, or forced motion. Divide the first equation with m, where Ft equals Ft per meter, and as in the preceding section, 2 lambda equals beta per meter. W power of 2 equals k per meter. When the absence of damping, beta equals 0, we will get this form of equation. Then, dividing by mass, it will be, for the underdamped motion, equation, xc equals c1 cos 4t plus c2 sin 4t, let x be equals a cos 8t plus b sin 8t. Then, substituting xp into the Absanya damping formula. Negative 48a is 8t minus 48b sin 8t equals 16 sin 8t. Based on coefficient, a equals 0 and b equals minus 1 per 3. So then, let x be equals 1 per 3 sin 8t. Thus, x equals xc plus xp. X equals c1 cos 4t plus c2 sin 4t 1/3 sin 8t. X prime equals 4c1 sin 4t plus 4c2 cos 4t 8 per 3 cos 8t. Then, substituting x prime, 0, equals 0. Thus, x t equals 2 per 3 sin 4t 1 per 3 sin 8t is required equation of motion. So how it is easy to determine equation motion. Okay, now we need to find what at times does the mass pass through the equilibrium position. When the xt equals 0 implies to the formula equation of motion that we find in part A, so then xt equals 2/3 sin 4t 1/3 sin 8t equals 0, and we refer to the basic trigonometry formula, which is 2 theta equals 2 sin eta cos eta, just simply the equation above. So then we simply the equation and then get 2/3 sin 4t multiplied by 1 4t equals 0 and sin 4t equal to 0, then sin nx when the n equal to 0, 1, 2, 3. So we get t equal to nx/4, so for the conclusion thus that t equal to nx/4, which is n equal to 0, 1, 2, 3, the mass pass through the equilibrium position.
Now, let's find the answer for question 1c. Question 1c is, at what times does the mass attain its extreme displacements? To answer the question, first, we need to differentiate the equation xt equals d over dt 2 over 3 sin 4t minus 1 over 3 sin 8d with respect to x to determine xt. And we get, xt, equals 8 over 3 cos 4t, minus 8 over 3 cos 8t. Next, substitute 0 for xt, and simplify the equation to determine the extreme displacement. We will get 0 equal to 8 over 3 time, 1 minus cos 4t, time, 1 plus 2 cos 4t. For 1 minus cos 4t equal to 0, d equals n pi over 2. And for 1 plus 2 cos 4t equal to 0, we get t equals pi over 6 plus n pi over 2. Therefore, the final answer is the mass attain its extreme displacements at d equals n pi over 2 and at t equals pi over 6 plus n pi over 2. Next, we need to solve question 1d, what are the maximum and minimum displacements? To determine the maximum displacement, substitute pi over 6 plus n pi over 2 for t in the equation xt equals 2 over 3 sin 4t minus 1 over 3 sin 8t. And through this calculation, we will get square root 3 over 2. Next, to determine the minimum displacement, we need to substitute n pi over 2 for t in the equation xt equals 2 over 3 sin 4t minus 1 over 3 sin 8t. And the answer will be 0. Thus, the maximum displacement is square root 3 over 2 centimeters and the minimum displacement is at 0.
By using all of the value, we can plotting the graph. So now we are done with the question number 1. Then let's proceed to solve for the question number 2. So here are the question for number 2. We need to find the steady state current in a LRC series. with the information given. Step 1. Let L be the inductance of the inductor. Let R be the resistance of the resistor. And let C be the capacitance of the capacitor. The Kirchhoff's second law for the system is, where Qt is the charge on the capacitor, and dt is the voltage impressed on the circuit, the equation can be transformed into. After that, insert this value into the differential equation. Is half an hour for L, 20 ohm for R, 0.001 for C, and 160 T plus 200 cos 40 T for ET. So get the differential equation for the charge Qt, which is d power of q per dt power of 2, plus 40 dq per dt, plus 200 q equals to 260 T, plus 400 cos 40 T. Yeah! We done with step number 1. I hope you understand how to calculate in steps 1. Now, we move on to step number 2. For step number 2, first things that we need to do is find the associated homogeneous dE. The associated homogeneous that we will get for this question is q double prime plus 40 q prime plus 2000 q equals to 0. Then, we change it into auxiliary form, in order to make it more easier. After that, we solve the equation. The answer that we will get is both x1 and x2 is negative 20. So, the solution would be, x1 equal to minus 20 to 40i, meanwhile x2 will be minus 20 plus 40i. Finally, we change the solution into complementary solution. The solution is then would be qct equal to, exponent power of negative 20t, which c1 cos 40t plus c2 sin 40t. After found the complementary solution, let's find the particular solution, using the method of undetermined coefficients. First, let's assume a particular solution, in the form of Qp, in the term of t, equal to, a cosine 60t, plus, b sine 60t, plus, c cosine 40t, plus, d sine 40t. Then, if we put that into the d, we get the coefficients of a equal to negative 3 over 52, b equal to negative 1 over 26, c equal to 1 over 17, and d equal to 4 over 27. Hence, the steady state charge is the particular solution, where Qp, in term of t, equal to negative 1 over 52, times 3 cosine 60t, plus 1 over 17, times cosine 40t, plus 4 sine 40t. Thus, the steady state current is the derivative of the steady state charge, which is Qp prime, in term of t. Therefore, Ip prime in term of t is equal to negative 15 over 13, times 2 cosine 60t, minus 3 sine 60t, plus 40 over 17, times 4 cosine 40t, minus sine 40t. Yippee! We have done all the question. I hope you can understand it well. That's all.